Hello class. In today's lesson we're talking about the angles of polygons. Okay? Let's make sure we understand what a polygon is. Okay? A polygon, a polygon again is an object that has sides. It must have sides. In other words, before we even get started, let me ask this question. Is a circle a polygon? No, it's not, because a circle doesn't have any sides. We're talking about triangles, rectangles, trapezoids, kites, pentagons, etc. Okay? Pentagon. Let's think about that. Pentagon. How does the pentagon, the wording, doesn't it end with the word gone? Exactly. And before we even get into the rest of the notes right now, let's think about one of the main, excuse my drawing, I'm trying to fix this up. What did I just draw? Right, a triangle. Okay, if we wanted to, we could call this triangle, we could call it a threegon. Notice you can name any polygon using the number of sides and with the gon. Now, we don't do that with triangles, so don't name your triangles threegons. And don't do that with your squares and quadrilaterals and etc. because they have specific names. But you use the number in gon, like if you had an object that had, let's say it had 70 sides. Well, there's not a name, so you could just call it a 70gon. Or if you had something that had 27 sides, you could call it a 27gon. Does that make sense? Okay, so going into our notes. First of all, you noticed these three terms here. Well, actually, those aren't new terms, are they? Let's think about the sides. Look at this object over here that has the letters C, B, A, E, and D here to the left. Okay, it's got 5 points, right? Well, notice the black edges. I'm kind of going to trace around them with my pen here. Okay, well, how many sides do I have right here? That's right, I have 5 sides. Okay, so yes, you could call this object a fivegon, but really, let's be proper and be correct, and you should be familiar with this word, but isn't it a pentagon, right? Okay, vertex. Well, there isn't a common word. We've been dealing with vertex or vertices all year long. Okay, but look at those points that I'm circling right there. A, B, C, and D, and E. Not only do I have 5 sides, but since I have 5 points to make the sides, doesn't that mean I also have 5 vertices or 5 angles? Right. So my vertex or my vertices, they are forming my 5 angles. Right? If I got 5 sides, I got 5 angles. If I've got 3 sides, I have 3 angles, and so on. Now, diagonals. We have dealt with diagonals, but usually it's been if there were parallel parts, etc., and so on. Okay, but I'm going to go ahead and use the red since the diagonals in your diagram are red. Okay, and there could be more diagonals than just the 2 that I just kind of highlighted in red in that drawing. But this is all a diagonal is of an object. A diagonal is going to start at one vertex of an angle, in this case, point B or angle B, and it goes across the object. See how B is going across to D? And there's not one drawn here, but look at C and E. Couldn't C and E be a diagonal? And that's right. C and E could. And here I'll do it in blue. That would also be another diagonal. Okay? All right. So, going down to this first theorem here. Before I read this theorem, there's a word that I want to point out that I'm circling right there. The word interior. We've dealt with interior a bunch, haven't we? What does interior mean? Inside, right? We're talking about the angles on the inside, interior angles. So the polygon interior angle theorem, this is what it says. And I'll read it right here. You can read along with me. The sum, what does sum mean? That's right, to add. The sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180. Well, I need you to point out something, that you have this polygon right here to the right. And let's look at the total number of sides. 1, 2, 3, 4, 5, 6. It has 6 sides. Well, this n that they're using for this formula, I need you guys to understand that n just means the number of sides. Okay? Well, in this case, our object has 6 sides right here, right? Not only does it have 6 sides, but if I was going to name it properly, it would be called what? A hexagon, right? You need to get familiar with that because we'll deal with hexagons a lot as we move forward. Okay? But let's look at this equation. Again, the equation to find the total degree measure of all the angles in the object is n minus 2 times 180. Well, again, we know how many sides we have. We have 6. So since we know what n is, we're going to plug in 6. 6 minus 2 times 180. Now, we've got to do order of operations first. So don't we need to subtract this 6 minus 2? Correct, we do. So 6 minus 2 would give us 4. And now we would multiply that times 180. And now we'll go ahead and multiply that. And my calculator gives me, sorry, it's getting kind of scattered right there, but I get a 720 degrees. I need you to understand what this 720 degrees represents. This is what it means. Since my object has 6 total sides, that also means that it has 6 total angles. And all 6 of those angles, whatever each one of those angle measures equals, they have to add up and equal this total. Okay? So let's do another example together. We'll do this example together, and then I'm going to let you guys try a problem on your own. So number 1, we'll read it here, and it says, find the sum of the angles on the polygon. Find the sum of the measures of the interior angles of the figure. So let's look at our figure at the right. Okay. So first of all, let's figure out how many sides it has. So there's 1, 2, 3, 4, 5, 6, 7, 8. And no, these aren't congruence tack marks I'm putting on here right now. I'm just trying to keep track of how many sides I have. So we have 8 sides, right? Let me ask you a question. If this polygon has 8 sides, how many angles does it have? That's right. It also has 8 angles, right? So that's what we're trying to figure out is what do all 8 of these angles have to equal when we add them together, just like in a triangle. In every triangle, no matter how big or small a triangle is, the 3 angles of a triangle have to add up to what? Yeah, 180. You guys have dealt with the triangles all year long so far and before now. So anyway, so we need to figure out what the angle measure is. Well, remember our little equation that we had just learned, which says n minus 2 times 180. And what do we say n represented? That's right, the number of sides. So now I'm going to substitute in 8 for n. Okay, so I have 8 minus 2 times 180. Again, what do I need to do first? Can I go ahead and multiply, or do I need to do the stuff in the parentheses first? That's right. I need to do the inside the parentheses first. So 8 minus 2 is 6. And so now I'm left with 6 times 180. And so my calculator, punch that in real quick, 6 times 180. And I get 1,080 degrees. Again, that represents that all 8 of my angles that I have that's in this object must add up to 1,080 degrees. So what I want you guys to do is I want you to go ahead and do monitoring progress number 1. I will kind of point out a couple things. They've given you this cone, and it has sides on it. Aren't they telling you how many sides it has right here? And so what they want to know, what is the total degree measure of all the interior angles? So go ahead and work this problem, and when you have an answer, go ahead and raise your hand before you move forward. So now we're on the second page of notes here. We're gonna kind of, I'm gonna do number 2, the monitoring progress, with you or for you, and then I'm gonna see how you can do number 3. But on number 2 here, it says the sum of the measures of the interior angles of a convex polygon is 1,440 degrees, and they want us to classify right here. They want us to classify what this polygon is by its number of sides. In other words, we don't know what n is, do we? But we do know the total degree measure. Well, if you remember on the previous page, we had an equation that allowed us to find, and when we knew the number of sides, or n, we could figure out the total degree measure. Well, here, don't we know what the total degree measure is? So we're trying to figure out the number of sides, so don't we just need to solve for n? Okay, so the first thing we do is, I want to get this n minus 2 by itself, so what's the opposite of multiplying by 180? That's right, we'll divide by 180. Okay, and when we do that, we end up getting n minus 2 equals 8, because 1,440 divided by 180 is 8. Now what do we do? That's right, we'll add 2 to both sides. That's gone, and we get n equals 10. So a polygon that has a total degree measure of 1,440 degrees has 10 sides, which also means it has 10 angles. Okay, I want you to do number 3. Pay attention to a couple things. First of all, the measures of the interior angles of a quadrilateral. So how many angles, or how many sides, what is your n going to be in a quadrilateral? That's right, 4 sides. So your n here equals 4. So when they give you that your 4 angles here, one of your angles is x, one of your angles is 3x, one of your angles is 5 times x, and your 4th angle is 7 times x, don't you know that those 4 angles, they have to add up to a total degree measure? So that's what you need to do first, is find your total degree measure of all 4 angles. Okay? And then you can solve this. So go ahead and figure out an answer. Find what x is so that you can tell me what all the angles equal. And when you think you have an answer, raise your hand. Okay, so now we're going to go ahead and go to the extending polygon classification. Okay, and a lot of these terms are things that we've already dealt with this year. For instance, an equilateral triangle. We dealt with equilateral triangles when we learned the different how to name triangles by their sides. And remember, an equilateral triangle meant that all the sides were congruent. So when we say an equilateral polygon, we're talking about it having all of its sides congruent. Okay, and you can see the diagram that goes showing equilateral. You can see the tack marks for the sides going around this object here. Okay, and then right next to it we have an equiangular polygon. Well, we had equiangular triangles, remember? That meant all 3 of the angles were congruent. Well, in an equiangular polygon, that means all the angles in the polygon on the interior are congruent. And you can see the marks here inside this polygon. All the interior angles have 1 arc, and so they're all congruent. Well, last semester I did introduce this word here, regular. Okay, we have talked about it in class before. I kind of went ahead and jumped the gun one day and introduced it. But anytime we say a polygon is regular, that means that the polygon is both equilateral and equiangular. And really, this is really, really important. If you're told something is regular, it doesn't matter if it's a regular triangle, a regular quadrilateral, a regular pentagon, any polygon, if it is called regular, that means, this is very important, all sides, okay, and all angles are congruent to each other. Okay, So let's make sure we understand what regular means. All right, well, let's do example 4 together. Okay. So in example 4 here, they have the home plate of baseball, or a baseball field. Okay, and what they want us to do, there's two different things they want us to do. The first one, they want to know, is the polygon a regular polygon? And they want us to tell why. Well, let's look over here. We're going to use red for right now. But look at the markings. You have angle A, angle B, and angle D. Well, those are three congruent angles, aren't they? Because those three angles, angle A, I won't write the symbol A, but A, B, and D, those are right angles, right? They add up to 90 degree, they're 90-degree angles. And not only that, but then you also have angle E and angle C. We don't know what they equal, but aren't E and C congruent to each other? But they're not right angles, right? So let me ask you a question. I have 5 total angles. I have 3 of them that are 90 degrees. And then I have 2 more that we don't know what they equal, but they are congruent. But are all 5 of my angles congruent? No, not all 5. And so this the home plate is not a regular polygon, because again, all the sides and all the angles must be congruent. So that's why it is not. So it is not regular. Okay, and also along with that, your explanation would be doesn't have all congruent sides, or it doesn't have all congruent angles. All right, well, they want us to do something else with this problem. They want us to figure out what the measure of angle C and angle E are. Okay, well, let's think about this. First of all, how many sides does the home plate have? Well, you really need to count the sides. Look at the points. You have A, B, C, D, and E. So you have 5 points. So if you have 5 points or 5 vertices, then that means you have 5 sides. And if you have 5 sides, how many angles do you have? That's right, you have 5. So we need to know, what does the total degree measure of a 5-sided object, or a pentagon? Now, we've done that. So let's go ahead and do our formula that we learned on the very first page, which is n minus 2 times 180. I know I'm going ahead and kind of going the wrong way, but it's good practice. So n is 5, right? So we put that in there. We got 5 minus 2 times 180. And 5 minus 2 is 3. And so now I have 3 times 180. And what you get is 540 degrees. So you know that your 5 angles here are going to be, have to add up to be 540 degrees. Well, let's remember something about our angles. What did we know? What did we know about 3 of the angles? Okay, and I'm going to use blue. What do we know about angle D? What do we know about angle A? And what do we know about angle B originally? They're right angles. So we have 3 90-degree angles. Well, 90 and 90 and 90 is 270. So wouldn't I take the 570 of all 5 angles, subtract it from the 270? And so what is 570 minus 540 minus 270? Well, it's 270. Well, why is that number right there important? Well, again, remember angle E and angle C? We just knew they were congruent. Well, there's 270 degrees left, and they are divided up equally. So what would I do? What would I need to do to figure out what angle C and angle E equal? Well, hopefully what you decided was that the 270 degrees that is left needs to be divided equally amongst E and C. And so, therefore, 270 divided by 2, right? I would divide that by 2, and that's 135. So angle C is 135 degrees, and angle E is 135 degrees. So what I would like for you guys to do is to have a little practice on your own, and it's a similar object here, but do this monitoring progress right here, okay, with the pentagon, PQRST. And so do 5 just do number 5 for right now. And then, or number 4, I'm sorry, I apologize for that. But do number 4 here where they want you to find angle S and angle T. And then when we get to the 5 where we're sketching something, we'll talk about that, do that together. Okay? So work those two real quick. Okay. So now we've been talking about the interior angles, talking about the interior angles, and talking about the interior angles. And now we're going to move on to the outside angles. And we've kind of touched on this before. But I need you guys to understand this. Exterior angles is very easy. The bottom line, it doesn't matter how many sides a polygon has. And I'm going to go ahead and write here, it doesn't matter if you have 3 sides. It doesn't matter if you have 4 sides, 5 sides, 6 sides, 7 sides, 8 sides, or 1,000 sides. If it's a polygon, the exterior angles, and remember what exterior is. If interior is inside, then exterior is outsides. Okay, but the exterior angles of every polygon, no matter how many sides it is, will always add up to 360. Period. The sum of the measures, it doesn't matter. So for instance, they have this object right here. Okay, n is 5. They tell you this object has 5 sides, so it has 5 sides. It has 5 interior angles, which we have a formula for that. But on the outside, there's 5 separate, you can see them right here, angle 1, angle 2, angle 3, angle 4, and angle 5. Those 5 angles on the outside. Well, doesn't matter how many degrees there or how many sides this object has. It's because what's going on is you're going around a circle in essence on the outside. And so any object, any polygon, triangle, square, kite, pentagon, hexagon, etc., the exterior angles will always add up to 360. Okay, so in this box, all polygons. I mean, there's no formula. All polygons, the exterior, and I'm going to abbreviate, the exterior angles add up to 360. It doesn't matter the number of sides. No, it does not matter. Okay? So, let's do example 5 together. Okay? So, let's look at this object. They want us to find the value of x. And when you look over here, as you can see, you have, first of all, it's a quadrilateral, right? You got this object here, it's got 1, 2, 3, 4. So there's 4 sides there. Okay, so that means there's 4 interior angles. But look at the angle measures. The angle measures are on the outside, right? And so they want us to find x. Well, when you look at this, 2 of the angles, right there and right here, have variables, and fortunately they both have an x. Okay, well here's the deal. Does it matter how many sides this object has? No. Since we're dealing with the exterior angles, all these angles have to add up to 360. Doesn't matter how many sides it has. So what I need to do is I need to add everything I know. So I have a 2x, I have an x, I have 67, and I have 89, right? And what does that have to equal? That's right. They all have to add up to 360. Well, now, just kind of combine stuff together and solve, right? First of all, can we add those two things? Yes, we can. 3x. And then 67 plus 89. You can use your calculator real quick. That's right, 156. And then I have 360 over here. I'm sorry, that kind of covers it up, but I don't have a lot of room. Maybe you have more room on your paper, but this is a little tight, so kind of stay with me here. I'll kind of darken that 360 in with the black. I don't thought I did. Try it one more time. There we go. Maybe if I use a marker, that'll make it better. 360. How's that? Okay, still kind of getting used to this. All right, so now it's a two separate equation, right? I have 3x plus 156 equals 360. Well, what do I need to do? Yep, subtract 156. Okay, I'm left with 3x over here. And then I got to subtract the 156 over here off my humongous 360 there. And when I subtract that, don't I end up with 204? Right? So I have 3x equals 204. Divide by 3. Okay. And what do you get for x? You guys use your calculator real quick. We'll see if your math works out with mine. That's right, 3 will go into 20, what, 6 times? Okay. Got 2 left over. And then 3 will go into 24 8 times. And so you end up getting that x equals 68. And so remember this problem. Of course, you have 60. This angle right here, it's hard to see. It was just x, so doesn't that angle equal 68, right? And then this angle here originally was the 2x, right? So if I put 68 times 2, that's going to be whatever that is. And then when I put in 68 and what 2 times 68 is, and I add all those together, it should equal 360. And if you check it, you will find that it does. All right. Well, now we're going to go ahead go to the last page here. Now we're going to deal with our regular polygons. Okay. Again, remember what we said, what regular polygons did. Okay. Regular polygons means what? Okay. First of all, it means all sides congruent. Is that it? That's right. And all angles are congruent. And so in between these two, I'm going to put that and symbol because when you say and, it means both of them. You have to have both to be regular. So anyway, they tell us right here that this trampoline shown in the shape is a regular dodecagon. Now I'm not going to be too concerned with you learning these names. And if you don't know how many sides an object has by the name, Google the name right now until we get more familiar with knowing what is what. But a dodecagon is a 12-sided object. Okay, so we know that we have an object that has 12 sides, right? So if we would happen to use that formula that we used earlier, the n minus 2 times 180, that's where we would use our n. So they want us to find the measure of each interior angle. Well, isn't this equation what we use for the interior angles, right? So that's what we would do, right? So we're going to plug in 12 minus 2 times 180. And 12 minus 2 is what? That's 10, right? And 10 times 180, really don't need a calculator for that, but it would be 1800, right? So our trampoline here that has 12 sides, the 12 angles here need to add up to 1,800 degrees, or 1,800 degrees, right? But here's the thing. They just don't want to know the total degree measure. Again, look at the problem. Find the measure of each interior angle. Do you understand why we can find the measure of each interior angle? That's right, because this object, they said, was a regular polygon, which means all the angles are congruent. So don't all my angles have to add up to be that equally, right? So how can I figure out if my 12 angles, that's right, take the total degree measure of all the angles and divide it by 12. And so real quick with you just go ahead and do your calculator real quick and tell me what that equals. That's right. You would get 15. So what that would mean is that each one of my, excuse me, that's not 15. That's right. Little slight mess up with my calculator, sorry about that. But 100 or 1800 divided by 12 would be 150 degrees. Okay, 150 degrees, meaning that each one of my angles would be that angle. And when I added up 12 of 150s, or 12 times 150, you would get 1800. Okay. Now, I'm running out of room right here, which is fine. What I want you to do on your own is I want you to find the measure of each interior or exterior angle. Remember, we talked about, does it matter how many sides your object is, about what the outside or exterior angles equal? No, it doesn't. So we have a total of 360, right? And let me ask you a question. If all the inside angles are equal, wouldn't all the outside angles be equal? That's right. If you have a regular polygon, not only are all the interior angles congruent, but also the exterior angles are congruent to each other. So therefore, your outside angles will each be the same. So do part B, and as soon as you have an answer, raise your hand before you go forward. Okay, so I'm going to end the notes right here. And we're going to come back to these last two problems on the monitor in progress. Okay, so for right now, what I need you to do is, as soon as you finish writing your notes, go ahead and bring me your notes and let me look at them so that you can receive your daily grade. And then once you do that, then I will give you your homework, and you can go ahead and get started. And if you have any questions, please tell me.